Hi, let's have a look at the answers then to question 5, all about mapping. Now, the first question was looking at the specimen from the photograph. I know it's much harder to do from a photograph than it is from the real rock, but here we're looking at a, a coral limestone. The lighter coloured areas here are fossil coral. If you look carefully, you can see the radial lines of the septa that make coral so strong. So this rock is part of the limestone unit on this bed, on this map, should I say. Question B then asks what type of fold it is. We can see that the dip arrows are pointing towards each other, so this is a sin fold. So to draw the appropriate symbol then, to show the axis, we have a line running down the middle where the symmetry is, with that like bow tie symbol to show the fact this is a sin fold. I then ask you to describe the texture of photograph E. We look for the size, the shape, the sorting. We can see that these grains are sand size. Most of them are between 1 and 2 millimeters across. They're quite angular in shape, and they've got some moderate sorting. They're similar sort of size, but they're not all the same size. This is part of the sandstone bed that we can see on the map. If you said it was part of the greywacke, then that's fine too. Question D then is all about how we apply our understanding of geological maps, how we use these maps. Now this site has been suggested as a possible dam site. The black line there represents where the dam would be. And there are two things that could make this a good place for it. Firstly, we've got some impermeable rock here. The shale down in the middle of the valley there will be impermeable. And the sin-form structure allows it to collect water. Water will run down those bedding planes, will run down the direction of dip and collect in the middle behind that dam. There are also some potential risks to this. The rock type, we've got some permeable limestone here. The limestone will let water through it. Okay, when water gets into rock like that, it can reduce the friction between these rock units with possible serious consequences. The structure as well also poses some risks. We've got really quite a steep dip here going into the valley. So particularly with water getting into them, some of these rocks might actually slide and fall into the reservoir and possibly even cause the reservoir to overflow. Now, it is possible to reduce this risk if you dug deeper. You could grout the limestone, you could pump a very wet liquid cement in there to block up the permeability. And of course, you can always bolt the slopes in place to stop them sliding. But there are problems with doing that, particularly if those rock bolts then are going to be underwater. There's potential there for corrosion. Okay, check how you've done against those answers. If you've got any questions, contact me.